Hey guys, this is Steven and I'm finally back with some more video tutorials for you. It's been a long semester and that was the reason for my absence and not getting the rest of that 1911 tutorial out to you guys. But before I continue with that, I want to actually go in and show you what I consider to be some intermediate level skills as far as the software goes, so that way as we start progressing through the tutorials again, you'll be a little familiarized with the tools before you watch me model them at a faster pace. So what I'm going to do is open up a new sketch, and you can see I'm on SolidWorks 2013 now, by the way, which if any of you are on a later version, this isn't really going to affect you too much because I'm not going to use anything that is exclusive to the newer versions. So if you're still on something older than this, you should be good to go. Open up a drawing here, and you can see from my previous tutorials this is a little different. What I did was I went ahead and I threw a bunch of templates in here for myself, so depending on what kind of dimensional standards I'm in, which actually I've got all these in ANSI right now, I can do metric or standard, and since our 1911's in standard, I'm just going to open up a standard part. And I can't recall if I showed you guys how to do sweeping or lofting in my previous videos, but I know I received a comment on one of my other ones regarding lofting. So we'll start with that first, and this is just going to be kind of like a doodle, so I don't really have a drawing for you guys to work off of. It's more of, you know, I guess you could just watch me model it and try to model something similar with similar or exact dimensions, whatever you'd like. But basically, the way the lofting command works is it's a geometric merger between two similar or uncommon shapes. So for instance, if we've got a square here, let me just throw some dimensions up on there. We'll make it a 2 by 2 square. And then I save this sketch. I don't want to go to features and do anything with it just yet. So I save this sketch and it just becomes a square. Next, what I want to do is, in order to loft this into a different shape, I need a separate sketch on a different plane. And what I need to do is set up a reference plane. So I'm going to go to Features, and then Reference Geometry, and select Plane. After that, this dialog box will pop up on the left here, and you can do up to 3 references, but it doesn't require all 3 in order to work. And since I sketched on the top plane, all I'm going to do is simply reference the top plane. And then you'll see my first reference will pop open with all the options. I can choose parallel, perpendicular, coincident. I can specify an angle relationship or just a distance, and that's actually what we're going to want to use since we don't want it to be directly coincident or perpendicular. So what I'm going to do is I'm going to choose 5 inches. And another thing you can do too is you can change the size of the plane after you're done. So I don't really have a good example as to why you do that here, but for instance, the plane is only going to be slightly larger than the surface you're projecting it off of. So let's say you want to project a plane off of a really small edge on a part. It's going to create a really small plane. But what you can do is, after you've created your plane, you can change the size of it so that it's easier to see when you're zoomed out on a larger part. So you can see I can create this plane as, you know, large or as small as I want. It's not going to change or affect your sketch in any way. It's simply making the plane easier and more available for you to select. So after I've got my plane situated there, I'm going to go to Sketch, and then let's do something fancy. We'll do an ellipse, and we're gonna use the same center as our square here and create our major diameter and our minor diameter, which will go a little bit larger like that. And then simply make this 1.25, and then let's do 2.5. And it needs some linear constraints so that it knows not to veer off on an angle. That one will work. And we'll finish this sketch. Now we've got two sketches which are completely parallel with one another, and they're not offset in any way or on an angle. So we can just go to Features, Loft, select Sketch 1, and then Sketch 2, and there's our lofted geometry. And sometimes it'll do something funky where, you know, if this is off this way, it's going to spin around and be irregular on you. I'm going to have to exit out so it doesn't do that. If it does do that, typically you can drag this around until the geometry or the mesh looks right to you, and then save it. There are ways of avoiding this altogether, which I'll show you in a few minutes here, but first I'm going to finish this so you can get an idea of what that looks like. So you can see we've gone from a square, and it's done a straight perpendicular merger into the ellipse, and it's symmetrical and even on all sides. And if we cut it, you can see that it is in fact a solid, so it's not doing that with surfaces or anything. It is a solid model, and you can, even from this point, if you wanted to, you could shell it. And we could do 1/16 of an inch. And you can see we've got shelled geometry, so it's kind of like a paper cup now or something like that. Oh, and actually, I guess I haven't even showed you the shell tool before. Shell, basically, it's going to create a wall thickness inside of a part, and it will imitate any external feature that you have created. So, for instance, even if I threw some fillets on the end of this here, we'll call it 1/2 inch. Let's see if it'll. Yeah, we'll fillet these. We'll make it nice and smooth looking. So if I've got this filleted all nice and round, and then I undo my shell, or I put the curtain below it, it will regenerate and rebuild that feature, and the inside will be the exact wall thickness of my outside geometry. And you can do other things with shell too, which I'll demo briefly on something else. This part's not really a good example for shelling, but I wanted to also expand on the lofting a bit and show you that you can do other things with it too. For instance, if you have, I'm in metric now, that's fine. For instance, if we had that same square, which now we'll do a 50mm square, and then let's say you had geometry that was not parallel or was on a different plane. Let's say we've got we'll pick the right plane and we'll go 100mm away. Now I'm going to sketch on this plane here, and create our ellipse again. I'll make this 60 by 25. Okay, so we've got our square and we've got our ellipse, and they're not planar, or they're not parallel either. They're perpendicular and offset. So we can also use the loft command to connect these two sketches. But the problem is, it wants to take the quickest, most efficient path there, which it's not necessarily what we always want. So even though this may be okay now because I don't have any design parameters, it's just a doodle. Let's say I wanted to have a 90-degree bend or an elbow join the two together. Well, in that case, I'm going to undo my sketch command here by deleting it, or my loft command rather. If I want a 90-degree elbow connecting these two, I need to draw some guiding contours, if you will. So what I'm going to do is I'm going to sketch on the plane that's perpendicular to both of these, which would be the front plane. And I can hide this one so we can see a little easier on our ellipse there. I can take a perpendicular line here and a perpendicular line here. If it'll let me grab that, there we go. And I'll just make those intersect. And it doesn't look like it wants to grab that point. There we go. Okay, so now I'll just throw a sketch fillet in here quick. Will work. And we'll hit OK. Now this is just one guide curve. So what happens with this, if I go to Features and Loft, I'm going to pick our sketches just like before, and then I'm going to come over here and go to Guide Curves, highlight the box, and select this sketch. And you can see it's not going to want to do it right away. And let's see if I can get it to fix itself. Okay, this is actually not correct. We need a sketch that touches the profile of both sketches. So I'm glad I could actually show you that, because if you try to use a guide curve as guiding the center of your geometry and not touching an edge, it will not function properly. You need to actually be touching the edges. So I'm going to draw this again here, and I'll just come off here. Okay, and then throw another sketch fillet in there. Now you can see that's one guide curve. I typically recommend doing no less than 2, because it will define your geometry a lot better in the loft than just 1. And more than 2 is even better, because it will help to define the outside profile of your lofted feature a lot further. We'll fill up this. Let's see if 100 will work. There we go. And we'll finish that. So you can see that's you can kind of see what it's already going to look like even before it's lofted. And we'll pick our 2 profiles, and then our guide curves. And then our second guide curves. And there it is. So you can see we went from a straight shot into a guided geometry, which better translates the 90-degree, the perpendicularity of our 2 sketches. And then just like before, if we wanted to, we could even shell this, and it will generate a hollowed out feature. And you could even shell this from both directions too. So if you wanted to shell it from here and here, it would create like a pipe or a tube. So that's pretty much the gist of the lofting command. Another command which is very useful is the swept command. And what a sweep lets you do is, it's essentially the same as a loft, but it doesn't change, it doesn't translate the profile of your shape into something else. It simply gives you the option to move a profile about a path. So, for example, let's do a square again, or let's do a circle this time. I'll do it this way. Okay, so we have a circle here. Now I need to sketch a path for it, so we'll go on the front plane, which is perpendicular to our circle here. And I'll draw a straight line and then connect it with a random spline. There. And just make sure these are tangent. Okay, so we've got our circle and we've got our spline. And in swept terminology, this is our profile and this is our path. So we go to swept boss and pick our, you can see what's highlighted in green is what it wants you to select, and then if you hover over it, it'll tell you what to pick. So we want our profile first, which is this sketch. It's automatically going to go and ask you for the path, so we'll just select that next sketch. And if your geometry is valid, it will generate a preview for you, and you just click OK, and there you go. You have a circle that is extruded along a predetermined path, which is called a sweep. And you can see, you know, just from this example here, it would be really useful for wiring or for tubing or something of that nature. In my applications, I generally use it for springs, and one instance of a use for it is braided springs, where, you know, if you want to, I'll just show you. I'll do another one quick. This will be like our little beginner model of a swept feature, and then I'll do a more advanced one here just to demo what it's capable of. So let's say I have a spring, which I will create the sketch and show you how to do that right away, because springs are something that are pretty essential in a lot of mechanisms. We'll do a spring, a vertical spring. We're going to start out with a circle that will define the diameter of our spring. And we'll do 50 millimeters again. And then we're going to go to Features, Curves, Helix, and Spiral. And I don't know why SolidWorks defaults to weird angles like this, but if you want to be able to sketch a profile along your helix, it's easiest to have it at 90 degrees or 180 or 30 or 360 or 270, something that's going to be related to your front or your right or your top plane. When you're at 250 or something like that, you're going to have to draw a different plane in order to sketch on the end of your helix. So we'll up here, if you choose defined by, you can pick pitch and revolution, height and revolution, height and pitch, or if you do a spiral, it'll simply project a two-dimensional spiral. I'm going to pick height and revolution. So I'm going to do a 100 millimeter spring with 25 turns, which is a little bit dense, so I'll make this 200 instead. That's better. Then I just click OK, and you can see it's generated my helical path, but it's not 3D geometry yet. So now I'm going to sketch and then pick a plane that is perpendicular to the end of my helix, which in my case it's the front plane. And then go to the end of your helix here and sketch whatever profile you want. I'm going to do a square just so I can show you something that's pretty neat with the sweep tool. So if I do a square here, and then I'm going to pick the center of my square and then rotate my geometry slightly so I can see it in 3 dimensions, hold Control and select the helix, and then I'm going to select the pierce relation. And that's going to attach the square at its midpoint to the end of my helix. And then we'll throw some dimensions on here. We'll make it a 5 millimeter square. And then finish that sketch. Now I'm going to go to Features, Swept Base. It already has my profile selected because I left it highlighted after I finished the sketch. So I'm going to select Path and then click my helix, and you can see it generates a square helix pretty nicely. But what if I want a braid or a twist in my profile? Well, I can extend the Options command, and it gives you a bunch of orientation options, and I'm going to do twist along path, and then you can define it by degrees, or you can define it by radians or turns. Turns are generally easiest, so I'm going to do 25 turns, which we'll go higher. We'll do 50 turns. I want it to be real dramatic so you can really see what it's doing. That should be good. And I do want to advise you that if you're on a lower end machine, doing geometry like this will definitely bog down your system. It takes a lot of RAM to generate and process that, so just be aware of that, that if SolidWorks starts acting real sluggish, it's because your geometry is becoming too complex. So what you can see it did right here is not only did it revolve or sweep our square profile along our helical path, it also twisted it. So we've created kind of like a twisted barb of some kind of rod, and it's a very nifty feature. One example that I used it in, as far as my own personal work goes, This is a hammer and trigger spring for an AK style rifle, and you can see it's a pretty complex model. And if you look at the end here, you'll see I've created what is essentially 3 wires which create the spring, but the wires are twisted, and they ultimately end up being a completed AK hammer and trigger spring. So that's a real world application for what I just showed you there. And let's see. The shell command. I was going to show you one more thing with the shell command, and then that should wrap up any of the other tools we would be using for the 1911 tutorial. We might not even use shell, but it's still pretty good to know. We don't need anything too complex for this. I'm just going to draw something really generic. Maybe throw a couple steps in here. Go this way with it, maybe. So if we've got this shape here, and we want to shell it, shell will do a lot of things. If we show it with a preview, you can see the minute I select this face, it's going to shell from this face only, and what will result is just this hollow cavity here. But what if you need multiple ends of this thing opened up? Well, with the shell command, you can select multiple faces, and it will open it up whichever way you want. So we can even do multi-thickness, like if you want to define how thick it is from a given face, you can say from here we want 5mm thickness, and from here we want 5mm thickness. So you can see it's built up the thickness of the geometry there, so when we cut it in half, the wall thickness is larger here than it is here. And that's the true versatility of the shell command, because you can have some pretty complex geometry and then say you actually intend for it to be hollowed out at some point. You can do all of the detailing you want on the outside, and once you decide to shell it, it's going to simply imitate that whole external shell and give it a wall thickness. So that was pretty much the shell command in a nutshell. No pun. Other than that, let me see if there's any other tools up here I'd want to go over with you guys quick. No, the other ones are pretty advanced. I don't see anything that it would be essential for us to know right offhand. As far as these tools go, I know I was asked about the loft specifically, and not necessarily the sweeping or shelling, but if you guys have any other tools you'd like to see, just feel free to leave me a comment, and I'm usually pretty prudent about getting back to you on that. And now that I've got some time off from classes, thanks to the semester being over, I'll have more time to create these videos for you guys. So I'm not gonna save any of these, but after this tutorial, I'm gonna get to work on the 1911 again, so it might be a couple days, but just make sure to keep looking, checking back for that, because I will be continuing that, and it is a project that I intend on finishing all the way to the end, so you guys aren't left hanging there. But thanks for watching, and I hope this one was educational, and I hope you check out the rest. Thanks.